All right, this is a pre-video on composing functions. We're going to spend some time on this in our next class session before we review for the exam that's coming up. But you want to be a little bit familiar about that before coming to class. That way you can start studying ahead. So there's two notations that we see when we talk about composition. F little circle G and G little circle F. F circle G, G circle F is how they write composite functions. What that means in math is we read it as f of g and g of f. So we replace the word circle with of. Now, that is a notation, and I like to write it a little bigger than the definition has it, for substitution. Essentially, this says f of g means take your f function and put the g function in as a substitution. So in other words, you're plugging one function into another function. If I want to do g of f, I'm going to plug f into the g function for all the x's. So essentially you take a whole function and plug it in for all of the x's in the other function. What's trickier about these is their domain. Notice that the domain of g, if you're doing f of g, goes to a g of x. That new g of x is going to be the domain of f. So you get this pattern of, if you need to evaluate, you need to plug into the inside function first, take the new answer and plug it into the outside function. So that's how we would evaluate. When we talk about composing, here's my steps on how to do this. So it says if we're composing f of g of x, which is f with g of x plugged in, I write f as a function with blanks everywhere there was an x. In other words, I think of it as an empty shell. That's how I like to think of it. So in this scenario, whatever's on the outside becomes an empty shell, where all x's turn into blanks. You fill those blanks in with whatever's g of x, whatever that function is. If it's x plus 2, you fill in all the blanks with x plus 2. Then you'll work out any powers, distributive properties, combine like terms. If you have fractions, make sure it's reduced. In other words, you just clean it up algebraically. To find the domain of a composition, you first start with eliminating values that do not work with the inside function. So I'm going to specify inside function, the one that got plugged in. Then you will need to look at not the other function, but the end result of your composition. So sometimes after simplifying down all of the stuff in step 2, you'll create new issues with what your actual problem is. So those are the two things. You look at the inside function for what needs to be restricted there, and you look at the end result to see if anything new needs to be restricted as well. Notice if you're doing g of f, you reverse this. So then g becomes the empty shell with all the blanks, and then you plug f into it, and then you would look at f for restrictions and end result. So it's just depending on which order they write the functions in. So for this first one that I want to do with you guys, we're doing a very simple polynomial. So notice f of x is 3x squared, g of x is x minus 1. I want to find f of g for a part. I go ahead and write that as f of g of x. Remember, that is f of g. So this says f is my empty shell. So I take the f and I say, okay, anywhere there's an x, I'm going to leave a blank. So that's my shell right there, that empty x. This one is going to be the inside function in this case, because I'm doing f of g of x. So I plug x minus 1 into that shell's blank. I then work this out. Obviously this needs to be FOILed since it's squared. So that would be x squared minus 2x plus 1 after we combine like terms, and then we would distribute the 3 out front. So this would be f of g of x. Now, I wrote the word inside here, but that's not always true for all of these. That was just for this example. On B part, we want to do g of f of x. Notice they put the g as the outside shell. That's how you know which one is the outside shell. The one that's farthest away from x is the outside. The one that's closest to x is going to be the inside. So g is blank minus 1 if we were to write it as a shell. And then in that blank, we write the f function, which is just 3x squared. There's nothing to really simplify here. There's no like terms. It's just what it is. So g of f of x equals 3x squared minus 1. You can also compose a function with itself. Now that's not always interesting, but you can do it. So C says do f of f. In other words, plug f into itself. So you write f as a shell again, and then inside the shell you write f again, so 3x squared. We square this, so this would be 3 times 9x to the 4th, and then we multiply. So notice that f of f is just 27x to the 4th. And just to show you can do this with g as well, we're going to do g with g plugged in. So g was blank minus 1, and then we put in x minus 1 is the inside as well. So this would be x minus 2. So there's g of g. Notice that in all of these I didn't ask you to do anything with domain. They just wanted you to practice composition at this point. So composition is purely just plugging one function that's inside into an outer shell of another function. All right, so let's look at example 4 because I do want you to see one where you have to evaluate something. So we're going to do f of g, and then we're also going to do g of f, and then we're going to evaluate them with these specific instructions for part C and D. So A is f of g, which would be f of g with g inside. So f is this function, 5. There used to be an x here, now there's not, minus 7. G goes in for this blank, so g is 3x squared minus x plus 2. I distribute the 5, and then combine like terms. So this is 15x squared minus 5x plus 3. So there's my f of g of x. For B part, I'm going to do g of f to show you that it's different. This time my shell is the 3 blank squared minus blank plus 2. All of these blanks are going to be f of x. So that's 5x minus 7, 5x minus 7. Notice that usually one way is going to be harder than the other to evaluate or to work out. This one's pretty bad because we have to square, but we also have to distribute. So this would be 5x minus 7 times 5x minus 7. I'm going to go ahead and distribute the negative right there. I need to FOIL out the 5x minus 7s. That's 25x squared. Minus 35 and minus 35 would be minus 70x. Negative 7 times negative 7 is positive 49. And then I still need to distribute that 3. I do not know what 49 times 3 is. It's 147. Then we combine like terms. So I have 75x squared, negative 210 and negative 5x would be negative 215x. 147 plus 7 would be 154, plus 2 more is 156. So this is g of f of x. Now, when you go to do the evaluations, you don't want to plug into the end result most of the time because that would be careless if you haven't paid attention to domain. In polynomials, it usually is fine, but it is careless if you're not dealing with polynomials. So the way we do this is we evaluate them one at a time. So if I want to do f of g of negative 2, I'm going to take a second and actually figure out what g of negative 2 is. So g of negative 2 is 3 times negative 2, because I'm using the g function, squared minus negative 2 plus 2. That's 3 times 4 plus 2 plus 2. That is 12 plus 4, which is 16. This is now the number I'm plugging into f, because I can now replace g of negative 2 with positive 16. So now I take my f function and I plug in 16. That would be 80 minus 7, or 73. I could check myself by plugging negative 2 into this. As long as there hasn't been any domain issues, it should also come out to 73. If there were domain issues, by the way, you would not want to evaluate it because that would be undefined. Now this other one, we're doing g of f of 3. So for D, we're doing g of f of 3. So we're going to find f of 3 first, which, remember, the f function was just 5 times x minus 7. So that's 15 minus 7, which is 8. So now we're going to be plugging 8 into the g function. G was 3x squared minus, let me look at my graph, minus 8, so minus x, so minus 8. Sorry, my pen's not wanting to respond. There we go. So minus 8 and then plus 2 at the end. So this was 3 times 64 minus 8 plus 2. 3 times 64 is 192 minus 6, 186. So notice that this is really just substitution and evaluation. That's all that's really going on here. Now I had 2 more that I wanted to do together on the pre-video, and then we'll save everything else for the beginning of our next class session, because there's a couple things we want to talk about with the domain, and I'd rather do that face-to-face. So I need to do f of g, which in this case would be f is blank cubed plus 2 blank squared, with g being 3x for each of those. That would be 27x cubed, because I have to cube this, plus 2 times 9x squared, for a total of 27x cubed plus 18x squared. So there's f of g. G of f would be 3 blank. And in the blank we put f, which is x cubed plus 2x squared. So that's 3x cubed plus 6x squared. So notice that was the easier one in that case. We needed to do f of g of negative 2. So I'll find g of negative 2 first. That would be just negative 6, it looks like. So I'm doing f of negative 6, which is negative 6 cubed plus 2 times negative 6 squared. Sorry, that's a weird negative 6. That would be negative 216 plus 2 times 36. And 2 times 36 is 72. And this will be negative 144 overall. And then we need to do g of f of 3. So we'll do f of 3 first, which is 3 cubed plus 2 times 3 squared. That's 27 plus 2 times 9, which is 27 plus 18, which is 45. So now I'm doing g of 45, which is just 3 times 45. And that would be, I believe, 135, yeah. All right, and then one more just to show you one more composition and evaluation process. Because all that's left on this is example 5, which has some variations, but that's just doing composition and then discussing domain. So f of g of x is f with a shell, which guess what? There is no x. That is the answer. If you don't have an x in the actual function, you can't plug something else into it. G of f, though, we can do because g has an x. It's blank squared. But you're plugging in the number 5, so it ends up being a number as well. It just ends up being 25. So f of g of -2, well, g of -2 is -2 squared, which is 4. F of 4, well, this always equals 5. It doesn't matter what x is. So it's going to equal 5. For g of f of 3, f of 3 equals 5, because this always equals 5 no matter what x is. Then we do g of 5. So this one's kind of a weird one because there's not really much going on, but that does happen sometimes. Now, if you're wondering what is going to be the focal point, I would say make sure you can do something like B or A. Those are both appropriate levels for what we could ask on a test. And you should be able to do some evaluations like we did in example 3 as well. So for composition, we don't get much harder than that on the exam, but definitely for your homework and just to have a well-rounded knowledge base, we want to make sure we talk about domain in class on Monday or Tuesday. So we have just a few more left. We probably won't hit all of those in class, just the ones that will give you a little taste of the domain issue. And that's it for the pre-video.